Today we are going to see about unit commitment problem. So in the last class we have seen the types of unit commitment problem like priority list scheme, then dynamic programming method. Then the next third one is Lagrange's relation method. Three methods are there. So in which today we are going to see about the priority list method. It is one of the easiest method to solve. With certain assumptions only, we are going to solve this problem. Dynamic programming method, we'll see in the next class. Priority list method is one of the easiest method. With certain assumptions, we are going to solve. How the priority list method we are going to solve now? By using the full load average production cost, that is FLAPC. Capital FLAPC is the full load average production cost. So priority list method is one of the simplest unit commitment solution method, which consists of creating the priority list of units. Okay. So by creating the priority list, what we are going to do is we are committing the generating units to meet out the demand. The priority list can be obtained by using this full load average production cost of each generating unit. So in short form, FLAPC, capital FLAPC, FLAPC, that is full load average production cost. So FLAPC is nothing but net heat rate at full load into the fuel cost. So how to calculate this net heat rate at full load? So net rate at full load. So H of PGI divided by PGA. That is the net rate. Okay, net rate at full load. HI is nothing but heat rate. Heat rate. So HI of PGI divided by PGI into the fuel cost. So the fuel cost we are taking here the notation as K. You can also take your own symbol like in rupees or dollars, like that also you can take. So for simplification, it is given like small p. So FLAPC, how to calculate FLAPC? FLAPC is equal to HI of PGI divided by PGI into K. That is nothing but fuel cost. Next, there are certain assumptions. There are certain assumptions in calculating this priority list method. So you just note down the assumptions. So first assumption, we are considering no load cost as zero. No load cost we are considering as zero. No load cost we are considering as zero. So next assumption is unit input output characteristics are linear between zero and full load. Units input and output characteristics are linear between zero and full load. So already we have seen the input output characteristics of fuel cost characteristics. That is, it is moving the linear. It is moving in the linear manner with the increase in the fuel cost, with the increase in the fuel cost, or with the increase in the heat rate. So automatically the power generation also will be increasing. So what we are doing is we are considering that as linear. So unit input and output characteristics are linear between the zero and full load. But usually in the practical case, so due to the ever increase in the load and due to the change in the demand, so it will be like not linear. Somewhat it might be linear, somewhat it might be decreasing, increasing. It might be non-linear. But here we are considering that as linear, and we are trying to solve the problem. Next third assumption is startup cost. Startup cost are of fixed amount. Startup cost are of fixed amount. But in practical, if you see like the startup cost, it might be varying. Okay, but here we are considering that as the fixed amount, and we are trying to solve the problem. But as I said, startup cost might be varying. Next, we have to ignore the minimum uptime and downtime constraint. That is maximum and minimum and maximum operating limit. That operating time constraints we are ignoring. So these are the four conditions these are the 4 assumptions we are following. So these are the 4 assumptions we are following for the priority list method. Next, what is the step number 1? Step number 1, we need to determine the full load average production cost. We need to determine the full load average production cost for each generating units. So how to calculate full load average production cost? We have already seen. So full load FLAPC is equal to HI of PGI divided by PGI into K. This K is nothing but fuel cost. Okay. Generally in the problem, like heat rate might be given. So based on the heat rate and also fuel cost also might be given. So you need to multiply this fuel cost in this heat rate. The whole divided by the PG. So next, form the priority order. Form the priority order based on average production cost. That is in ascending order. After calculating this FLAPC, so what we need to do is we need to sort that is in the ascending order. Okay, that is called the priority order. Form the priority order based on the full average production cost. That is based on full load average production cost. FLAPC. Next, commit the number of units corresponding to the priority order. So we need to commit the generating units corresponding to the priority order. So whatever the priority order we frame, according to that we need to commit the number of generating units. Next, calculate the PG1, PG2 up to PGN for economic load dispatch problem for feasible combination 1. Next, we need to calculate the already we solved now PG1, how to calculate PG1, PG2, PG up to PGN. You already know from the economic load dispatch problem for the feasible combination, whatever the combinations that is being given. For that combination, we need to calculate the economic load dispatch problem. Next, for the load curve, for the given load curve, the load is for each hour, the load is varying. Okay, so we need to consider for each hour the load is varying. Okay, so the load each hour the load is varying. It is not a constant one. So if each hour the load is varying, assume the load is dropping or decreasing. Okay, either the load curve we have already seen the previous classes. Load curve we have already seen. So if not, you just go through the load curve concept. So assume the load is dropping or decreasing. Determine whether dropping the next unit will supply the generation and the spinning reserve. Okay, assume the load is dropping or decreasing, and also determine whether the dropping the next unit will supply the generation and spinning reserve. So that also we need to calculate. So if not, okay, if this condition not satisfied, if not, continue as it is. Not continue as it is. If yes, then go to the next step. If yes, then go to the next step. Next step. Now, what is the next step? Determine the number of hours H before the unit will be needed again. Determine the number of hours H before the unit will be needed again. So number of hours we are taking as H. So we need to determine number of hours. Okay. So how many hours that unit, that particular generating unit is in operation? Say for example, first generating unit. So first generating unit, how many number of hours that first generating unit is in operating? Okay. So before that unit will be needed again. So we need to determine the number of hours before the unit will be needed again. So next, check H, capital H is less than minimum shutdown time. So there might be the minimum shutdown time for each generating unit. Okay, so it is not a simple thing. It is not simple thing like if you on the ceiling fan, you can ceiling fan or your light like that. Easily you can shut off and easily you can on. Okay, that is very easy. But this is the generating unit. Okay, you should not simply on and off simply like that. Okay, if you are on like ceiling fans or ceiling motors or like that, it is not at all possible. So there is a minimum time. Okay, minimum shutdown time is there. Okay, once the unit is being committed, that's what we have seen in the constraints. Once the unit is committed, there is a minimum shutdown time. Okay, minimum that unit it should go on for 1 hour or to the maximum of 5 hours or 4 hours. It might be depend on the which generating unit we are choosing. Okay, so if yes, go to the last step. If yes, go to the last step, or otherwise, if not, go to the next step. If this condition satisfied, go to the last step. If not, go to the next step. Okay, so calculate this two cost. Okay, two cost. Sum of the hourly production cost for next hour, next H hours with the unit upper. Okay, sum of the hourly production cost for next H hours, capital X H hours with the unit upper, and next recalculate the same for the unit down startup cost for either cooling or banking. Okay, cooling or banking already we have discussed. If the second case is less expensive, the second case, say for example this second case, recalculate the same for unit down startup cost for either cooling or banking. If this is, let's say, expensive, then you need to on. Then the unit should be on. Then the particular unit should be on. So repeat this procedure until the priority list. Repeat this procedure until the priority list. If not, go to the last step. So if yes, if yes, go to the last step. If yes, directly come to this last step. Repeat this procedure until the priority list. If not, again you need to calculate this two cost. Okay, you need to sum of the hourly production cost for next H hours with the unit time upper, and recalculate the same unit for the unit down startup cost for either cooling or bank. So this two step you need to continue. Okay, so this is the algorithm for this unit commitment problem for priority list method. Priority list method. So sometimes in 5-mark question like that they may ask. Sometimes a 10-mark question they may ask. But majorly it is very simple. So most probably it might be asking the 5-mark question. So if 5-mark question is asked, so you need to write this algorithm. This is the algorithm with certain assumptions. We have seen the assumptions. This assumptions with certain assumptions, we need to solve this, and we need to proceed this particular problem. Next, coming to the problems. Constraints we have already seen. Next, directly coming to the problem. Take out the example problem number 1. Determine the priority list. Determine the priority list using full load average production cost. Determine the priority list using the full load average production cost for the data given. For the data given below. So here also 3 generating units is given. Sometimes 2 generating units will be given. Sometimes 5 generating units will be given. So whatever the generating units is being given, so you need to solve. The method is common only, same for all the units, but you need to solve. Then the minimum and maximum of loading limits. Minimum and maximum loading limits is being given. Is megawatt. Okay, all the things are given in megawatt. I think here it is missed. Okay, so minimum loading limits. Minimum loading limits for first generating units is 100 megawatt to the maximum of 400 megawatt. Okay, so the fuel cost fuel characteristics also given. Okay, it combines of A, B, and C. Now, sometimes A and B and C is being given. So A is nothing but 0.006, then B is 7, C is 600. Then fuel cost is being given. Fuel cost is being given, that is 1.1. Okay. Similarly for generating unit 2. Generating unit 2 also it is given. Minimum and maximum loading limits 50 megawatt to maximum of 300 megawatt. Next, fuel cost parameter also given. Fuel cost parameter 0.01. That is A as 0.01, B as 8, and C as 400. Then the fuel cost for second generating unit is 1.2. Next, third generating unit, minimum and maximum loading limits is being given. That is 150 megawatt at 150 megawatt minimum to the maximum of 500 megawatt is given. And A, B, C is 0.008, B is 6, then C is 500. What is the fuel cost? 1.0. That is also is given in the problem. Fuel cost also given in the problem. So based on that, this heat rate we need to frame, or otherwise sometimes in the problem itself it is given. Sometimes instead of this table, what they will do is they will give the directly this table alone. So you need to frame the heat rate from this table. Sometimes how they will give us, they will neglect all these things. Simply like that, they will give directly this heat rate, and with the minimum and the maximum loading limits also will be given, and the fuel cost for that particular generating units also separately will be given. Okay, so either whatever the data is being given, you need to convert that similarly, or otherwise if this is given, you need to take directly, or this tabular column format like that given, that also you need to take. So similarly you need to take. So what is the first step in the priority list method? You need to formulate the FLAPC, that is full load average production cost. Full load, how to calculate the full load average production cost? So FLAPC of first generating unit is calculated by that is HI of PGI divided by PGI into KI. So KI is nothing but fuel cost, as I already said. So you can also write like fuel cost I, or KI, or rupees of I, or dollar of I. So all are same. Okay. In some other countries they are following dollars. In our country we are following rupees. In some other countries we are following some other fuel cost. So whatever the data is being given, this formula is same only. So there you need to substitute the fuel cost. So FLAPC of I is equal to KI into HA of PGI divided by PGI for I is equal to 1 to n. So here 3 generating units only given. So 1, 2, 3. So how to calculate? So you need to calculate FLAPC for 3 generating units. Okay. So FLAPC of 3 generating units for first generating unit. So in that you need to substitute PGI is equal to PGI maximum for each generating unit. So for unit 1, I is equal to 1. So FLAPC 1 is equal to K1 into H1 of PG1 divided by PG1. So here by substituting PG1 as PG1 maximum. PG1 maximum. So what is the maximum loading limit is being given? That is 400 megawatt. Maximum loading limit for first generating unit is 400 megawatt. Similarly for second generating unit 300 megawatt. Similarly for the third generating unit, maximum loading limit is 500 megawatt. So that you need to substitute over here. So here for first generating unit, so you need to substitute PG1. Okay, PG1 is equal to PG1 maximum. So that is 600 megawatt. That is 600 megawatt here. Okay, that is 600 megawatt here. Sorry, yeah, 600 megawatt here. I think here the data is wrongly given. Yeah, PG1 is equal to PG1 maximum. So the maximum value here it is given. The maximum value here, here it is given, that is 600 megawatt, 400 megawatt, and 500 megawatt. This is the loading limit. This is the minimum and maximum loading limit. So this is the maximum value. This is the maximum value. So here, what we are doing, we are taking this PG1 as PGI maximum. That is as 600 megawatt. 600 megawatt. So by substituting the 600 megawatts, heat rate already given. Heat rate H1 is already given. That is 0.006 PG1 square plus H7 into PG1 plus 600. Heat rate already given. So what we need to do is we need to substitute PG1 as 600 megawatt, and we need to further proceed. We need to calculate FLAPC 1. Okay, so if you calculate and K1, what is the fuel cost of first generating unit already given in the problem? That is 1.1. Okay, 1.1 already given in the problem. That also you need to substitute over here. So after calculating, after further simplification, you will get what 11.99 rupees. So whatever the rupees or dollars, whatever it is given. So it is the full load average production cost. So that is 11.9. Next, unit number 2. So that is I is equal to 2. So if you substitute in general formulation, so FLAPC 2 is equal to K2 into H2 of PG2 divided by PG2. H2 of PG2 divided by PG2. So here PG2 is equal to PG2 maximum. So what is the PG2 maximum value that is being given? That is as 400 megawatt. 400 megawatt. So here you need to substitute 400 megawatt. So FLAPC 2 is equal to, so this cost, what is the cost is being given here? So here the cost is 1.2 already given in the problem. Okay, fuel cost of second generating unit is 1.2. So here heat rate characteristics already given. So you need to substitute PG2 as that is 400 megawatt. So 400 megawatt, if you substitute here the general formulation equation, so you will be getting as 14.8. So FLAPC 2 as 14.8. Similarly for unit 3, I is equal to 3. So FLAPC 3 is equal to K3 into H3 of PG3 divided by PG2. So here PG3, we need to substitute PG3 as PG3 maximum. So here FLAPC 3, we need to calculate. So same like that substitution here PG3 as 500 megawatt. That is PG3 500 megawatt is already being given in the problem. So here you need to substitute. You need to substitute. That is K3 already given in the problem. That is 1. Then that heat rate equation, you need to substitute PG3 as 500 megawatt. Okay, and further you need to further simplification, further calculation, you'll get 11. So FLAPC as 11. So next step, what is the next step? You need to formulate the priority order. The algorithm, what is the next step? You need to formulate the priority order. So priority order based on this FLAPC. So how to formulate the priority order? So you need to sort it in the ascending order. You need to sort it in the ascending order, and we need to, based on the ascending order, we need to sort. Okay. So if you sort in the ascending order, which is coming less over here, which cost is which FLAPC cost is less over here, that is third generating unit is less over here. So next is the first, next is second. Okay, so like that you need to sort. If you sort, then FLAPC. So if you sort, so you need to formulate the stapler column unit. Based on the FLAPC, you need to. So first is third generating. So this is 3. Second is first. So first. So next one is the second generating. So what is the FLAPC? We already calculated full load average production cost. That is first one is in the ascending order. That is third generating. Third generating unit is 11. So first generating unit, that is 11.99. Next, second generating unit is 14.8. So minimum and maximum operating loading limits, minimum and maximum loading limits already given in the problem. So from the problem you need to solve. From the problem loading limits, minimum and maximum loading limits. 100, 400, 100 megawatt to 400 megawatt, 50 megawatt to 300 megawatt. Next, 150 megawatt to 300 megawatt. So unit is very, very important. So this is a minimum and maximum operating limits. That is minimum and maximum. So you need to take that particular third generating unit, that is 150 megawatt to 500 megawatt. Then first generating unit 100 megawatt to 400 megawatt. Second generating unit 50 megawatt to 300 megawatt. Next, after formulating this priority order, we need to formulate the unit commitment. We need to go for the unit commitment. So whichever the combination, if you go for, then you can easily satisfy the minimum and maximum combination, minimum and maximum operating limit combination. That also you need to go for. So how to calculate this? How to formulate this combination? So already we based on the priority order rule. So already we have seen in the this one the algorithm itself. So based on the algorithm, so we based on the priority order, we need to formulate this combination. So how to formulate this combination? So if you follow this priority order, and we can easily frame this combination. So so first combination we can go for 3 plus 1 plus 2. That is third generation plus 1 first generation plus second generation. 3 plus 1 plus 2. So what is the minimum and maximum combination from this 3 plus 1 plus 2? That is, so if you need to add it, that is 150 plus 100 plus 50. That is the minimum combination. Next, what is the maximum combination? 50 plus 500 megawatt plus 400 megawatt plus 300 megawatt. So 150 plus 100 plus 50. So 150 plus 100 plus 50 is 150 plus 100, 250. 250 plus 50 is 300. So 300 megawatt. So here also you need to add. So 500 plus 400, 900. 900 plus 300, 1200. This is the maximum combination. Okay. So maximum megawatt, maximum power generation from this combination. Minimum generation from this combination. So with this three combinations, so whatever the generating units if you choose, so it might be satisfying within this. Okay, so say for example, if you go for some other whatever the combination, it might be within this minimum and maximum combination. So next combination, how to choose? Next combination we can choose like 3 plus 1. 3 plus 1. So 3 plus 1. So what is the minimum combination from this 3 plus 1? So 150 plus 100. That is 250 megawatt. So here, what is the maximum combination? 500 plus 400. 500 plus 400 is 900 megawatt. So that is this minimum and maximum combination. So next one is the third one. Third combination. So what is the combination? What is the minimum combination? 150 megawatt. So 150 is the minimum combination. What is the maximum combination? 500 megawatt is the 500 megawatt. Directly you can take. So all the three units would be held until the load reached 900 megawatt. Okay. So if the say for example, if you want whatever the combination, if you keep, say for example 3 plus 1, based on the priority list only we are doing this combination. 3 plus 1, say for example 3 plus 1 you want to maintain in this combination. That is also possible because 3 plus 1 minimum combination is 250. So here minimum combination is 300. Okay, so that is also satisfied. Here maximum combination for 3 plus 1 is 900. Here it is 1200. That is within the 900. Within the 900, you can if you go for 900 megawatt, it is also satisfying within all the combination. That is 3 plus 1 plus 2 combination also it is satisfying. Say for example some other combination, whatever the combination, but based on the priority list method, if you are not following the priority list method, but you need to frame the priority list method. So then only it is very easy to frame the, so whichever the minimum generation capacity we need to choose, whichever the maximum generation capacity we need to choose for the power generation. Like that, you can easily choose. Say for example, third generating unit. So from the third generating units also you can easily go for this combinations. Okay, third generation unit, either from the third generating units you can also go for this combination, that is 250, this 3+1 combination. Okay, so this is also within 150 is within this 250 limit, and 500 also within this 900 limit. So that is what here it is. All the three units would be held until the load reached 900 megawatt. So all the three generating units would be held until the load reached 900 megawatt. Okay, 900 megawatt. If the unit 1 and 3 would be held on until the load reached 500 megawatt. So unit 1 and 3 or unit 3 and 1 would be held on until the load reached 500 megawatt. Next, then the unit 1 would be dropped. Next, the least combination, the unit 1 would be dropped. So the maximum combination from this is the unit, then the unit 1 will be dropped. The unit 1 will be dropped, then it is 500 watt. Okay, so unit 1 would be dropped. Okay, so here if you see this combination, that is what here also said. All the three units would be held on until the unit until the load reached 900 megawatt. That is, if all the three combination until the load reached 900 megawatt. If you follow this 3+1 combination, would be held on until the load reached 500 megawatt. Next, simply the unit 1 would be dropped. Okay, so whatever the combination if you say for example 500 megawatt you need to generate. So which generating unit you will be choosing? You will be choosing the third generating unit, because 500 megawatt you can easily generate. Say for example, you need to generate 1000 megawatt, or at the maximum megawatt, the demand is 1200 megawatt. So you need to go for 1200 megawatt only. Okay, in practical I am telling, practical, like you need to switch on 1000 megawatt, and as well as you need to switch on another 200 megawatt, or otherwise you need to switch on two 500 megawatt and one 200 megawatt. Like that you can go for. So whichever the generating unit that is being in the operation, that particularly you can choose, or whichever the least cost generator, based on that you can choose for generating maximum demand. Say for example, if the like a demand is 900 megawatt. So how you 900 megawatt means you have this three generators. How to on say for example the demand is 900 megawatt. How to on this for satisfying 900 megawatt? Which two generating units you should on? If you on 3 and 2, it is coming only. If you on 3 and 2, it is coming only 800 megawatt, because you can't able to satisfy. Okay, only if you want to generate 900 megawatt, you should choose this two combination one, 3 and 1 combination one, so that the maximum megawatt you can satisfy. Say for example, demand is being given like only 500 like 500 megawatt. 500 megawatt within this 500 megawatt, you can simply manage this 400 megawatt demand also. You can simply manage this 300 megawatt demand also. Okay, because maximum we are generating 500 megawatt. So either say for example, the demand is 300 megawatt. So you can simply on 500 megawatt. Then if the demand is 400 megawatt, you can simply on this 500 megawatt generating. Okay, and if you see like, so whatever the combination, say for example 800 megawatt you need to generate. 800 megawatt you need to generate. You can go for 3+2 also, but the maximum combination you can go for 900 combination. Or if you want to generate 800 in practical, if you want to generate 800 megawatt, sometimes what they will do is they will on 500 megawatt the thermal generating units, then another 500 megawatt generating unit. Because in the hydro only you will be having 100 and 200 megawatt like that. Or like if you go for hydro-thermal combination, then they may on one 500 megawatt combination, then another 300 megawatt, that is 100 and 200 megawatt from hydro power station. So whatever the combination we can do, it should satisfy that demand. So that is very, very important. So that's why we are going for simply like a priority list method. That is priority order. If you frame, easily you can frame this combination. That is the method. That is the algorithm that is being given. So based on the algorithm, we are framing the priority order, and we are sorting that like full load average production cost in ascending order. So based on that, we are choosing that particular generating units so that it satisfies the demand, power demand. This is the first example problem. So next we will move on to the second example problem. So what is being given in the second example problem? Obtain the priority list. Obtain the priority list of unit commitment using full load average production cost for the data, for the given data with the demand of 550 megawatt. So here the demand is being given. Okay, with the total demand of 550 megawatt. We have to follow the priority list by using full load average production cost. So here directly heat rate is directly given. Okay, in the previous problem we need to frame the heat rate, but here directly heat rate is being given. So whatever the given in the problem, accordingly you need to formulate heat rate and the minimum and maximum constraints like that you need to formulate. Okay, so heat rate, what is the heat rate for unit number 1 is given. H1 is equal to 510 plus 7.2 Pg1 plus 0.00142 Pg1 square megawatt per hour. Next, heat rate for unit 2, H2 is equal to 310 plus 7.85 Pg2 plus 0.00194 Pg2 square megawatt per hour. Next, heat rate for unit 3. Heat rate for unit 3, H3 is equal to 78 plus 7.97 Pg3 plus 0.00482 Pg3 square megawatt per hour. This is the heat rate already given in the problem. So how to formulate the full load average production cost? Full load average, what is the step number 1? We need to formulate the full load average production cost. Full load average production cost, that is FLAPC of I is equal to Ki into Hi of Pgi divided by Pgi for I is equal to 1, 2, 3. So 3 generating units is being given. So we need to substitute Pgi is equal to Pgi maximum for each value. So what is the unit number 1? I is equal to 1. I is equal to 1. And also minimum and maximum like a megawatt, that is loading limit, operating limits, loading limits also, it is being given in the problem. That is minimum first generating unit is 150 megawatt to the maximum of 600 megawatt. So fuel cost of first generating unit is 1.1. Okay, so second generating unit is minimum and maximum operating limit is 100 megawatt to the maximum of 400 megawatt. Fuel cost is 1.0. Next, third generating unit, minimum operating limit is 50 megawatt. Maximum operating limit is 200 megawatt. Fuel cost is 1.2. 1.2. So what is the first step? We need to formulate the FLAPC. FLAPC of first generating unit is FLAPC 1 is equal to K1 into H1 of Pg1 divided by Pg1 by substituting Pg1 as Pg1 maximum. By substituting Pg1 as Pg1 maximum. Similarly, based on the heat rate, we need to substitute Pg maximum. What is the Pg maximum that is being given in the problem? So here the problem itself we can take that is maximum value as 600 megawatt. Next, what is the next? That is 400 megawatt. PG2 has 400 megawatt. Next, like a third generating unit, the maximum is 200 megawatt. So similarly, we need to substitute 600 megawatt in the heat rate 1. Okay, heat rate 1, and this is already given. K1 is already given. That is 1.1. So based on this substitution, you need to calculate this in the scientific calculator. So based on this, you can clearly calculate this FLAPC 1 is equal to 9.79. You can easily calculate. Next, unit number 2, that is I is equal to 2. So that what is the FLAPC 2? FLAPC 2 is equal to K2 into H2 of PG2 divided by PG2. So what is PG2 maximum? Here we need to substitute PG2 as PG2 maximum. PG2 maximum already given in the problem as 400 megawatt. Already given as 400 megawatt. Okay, so simply like that, you need to substitute 400 megawatt over here. Next, what is the unit number 3? Unit number 3, sorry, PG2 has 400 megawatt, and further you need to simplify. You need to calculate. You will be getting answer as 9.4. So for the first FLAPC 1, you are getting as, we are getting as 9.79. Second FLAPC 2, we are getting as 9.4. Similarly for third generating unit, that is I is equal to 3. Third generating unit, we need to calculate FLAPC 3. So what is how to calculate FLAPC 3? So FLAPC 3 is equal to K3 into H3 of PG3 divided by PG3. So here PG3 is equal to PG3 maximum. So what is the PG3 maximum? Already it is given in the problem. PG3 maximum is given in the problem as 200 megawatt. 200 megawatt, simply like that, you need to substitute over here. You need to substitute over here. So FLAPC 3 is equal to, so whatever the K3 you are getting as 1.2. 1.2 you need to substitute, and the PG3 already it is being given in the problem as 200 megawatt. So 200 megawatt you need to substitute. So further substitute and simplification, we are getting as 11.88. I hope similarly you are also doing the problem in your note. Next, we need to frame the priority order. We need to frame the priority order. How to frame the priority order? We need to arrange the FLAPC in the ascending order. We need to sort. We need to sort the FLAPC in the ascending order. So how ascending order means, so whichever is least cost, we need to sort. So whichever is the least cost, I think the unit number 2, generating unit 2 is the first one. Then we can go for unit number 1 and unit number 2. So 2, 1, 3. So based on that, we already calculated. We need to tabulate this. We need to tabulate this. So what is the FLAPC of unit number 2 is 9.4. 9.4. Next FLAPC of unit number 1 is 9.7. That we need to write here, 9.7. Next, FLAPC of unit number 3 is 11.8. 11.188. 11.188. So here we are sorted in the ascending order. Next, what is the minimum and maximum megawatt? Minimum and maximum operating limits. That is minimum and maximum loading limits. That is already given in the problem. Similarly, so whatever the generating units you are sorting out, so that minimum and maximum operating limit you need to substitute over here. So here for second generating unit, minimum and maximum is 100 megawatt to maximum of 400 megawatt. So here unit is very, very important. If you miss this unit, then this tabular column of no use. Okay. Next, maximum operating limit. This 400 megawatt. Similarly, for first generating unit, 150 megawatt to the maximum of 600 megawatt. Similarly, for third generating unit, to 50 megawatt to the maximum of 200 megawatt. Similarly, you need to write according to the third generating unit, according to the first generating unit, you need to write this minimum and maximum operating limit. Next, you need to frame this unique commitment. You need to frame this unique commitment. The combination you need to frame. This is the priority order we already framed. Next thing is that we need to commit the units based on the this FLAPC. Based on the FLAPC, you need to commit this generating unit. So what is the combination we can do? We can do like 2 plus 1 plus 3. Second generating unit plus first generating unit plus third generating unit. So what is the minimum combination? That is 300 megawatt. So you need to add this 3 generating units. 100 plus 150 is 250 plus 50 is 300. Next, similarly here 400 plus 600 plus 200, 1000 plus 200, 1200. This is the maximum 1200 maximum combination. Maximum megawatt from the combination. Minimum megawatt from the combination. Next to 2 plus 1. 2 plus 1 is 100 plus 150. 100 plus 150 is 250 megawatt. Next, maximum combination is 400 plus 600. So that combination is 1000 megawatt. 1000 megawatt. So next combination is 2. Second generating unit. So that is 100 and 400 megawatt. Okay, so all the 3 units would be held until the load reach and 1000 megawatt. All the 3 units held until the load reached up to 1000 megawatt. So what is the demand is being given? Demand is being given in the problem. Here the demand also given in the problem. That also you need to, demand is being given as 550 megawatt. So based on the demand, demand is being given as 550 megawatt. So unit 2 and 1. Unit 2 and 1 would be held on until the load reached 400 megawatt. Unit 2 and 1 held on until the load reached 400 megawatt. Then unit 1 would be dropped. Then simply unit 1 would be dropped. Okay. So unit 2 alone. For the demand of 550 megawatt, which to say for example, if you want, if the demand is 550 megawatt, I want to generate 550 megawatt. Which 2 generating unit you will choose? Which 2 generating unit you will choose based on this? Because if you go for this second unit combination alone, you can generate only 400 megawatt. In that scenario, you can't able to manage the demand. Okay, for satisfying the 550 megawatt demand, you need to choose this 2 plus 1 combination 1. You need to choose this 2 plus 1 combination 1. That is maximum megawatt generation from this 1000 megawatt. But even though our demand is 550 megawatt, but you need to choose this 2 combination only for satisfying the load demand of 550 megawatt. Okay, if you choose only 2 second generating unit alone, then only you can generate 400 megawatt only. Okay, if the maximum megawatt from the 400 megawatt, some losses also there, some transmission also loss might be there. I think that you might be dropping around 15%. Like say for example, if you drop like 15%, some 2 or 20 megawatt, 30 megawatt deficit will come. Again, it will drop. And definitely for 550 megawatt, definitely 400 megawatt, 150 megawatt deficit is 150 megawatt deficit is there. That is very, very huge amount. Even some 0.5 megawatt or 0.25 megawatt, that you can simply manage. But 150 megawatt is of very great amount. So definitely you have to go for this combination only for generating the 1000 megawatt for satisfying the load demand of 550 megawatt. Okay, so like this the problem will come. So whatever the demand is being given, so you need to choose that particular combination and you need to write, and also you need to go for the unit commitment for all the combination, and you need to write the particular combination. So here in the first problem, you see in the first example problem, I think no demand is being given. The first example problem, here in the first example problem, no demand is being given. So simply like that, in some other problem, they might be giving this PG1, PG2, PG3 the problem itself. So here, I think here in the problem itself, it is being given that is PG1, PG2, PG3. In the problem itself, it is given as 600, 400, and 500 megawatt. The problem itself, it is being given. So directly we have taken. Directly we have taken. Or otherwise, what you need to do is, based on from this, you need to go for economic load dispatch for calculating PG1, PG2, PG3. From that PG1, PG2, PG3, you can substitute, or otherwise you can consider. Sometimes you can consider from this minimum and maximum. Here it is loading limits. Okay, here it is loading limits. Okay, so directly we have taken like taken as 600, 400, and 500 megawatt. Okay, sometimes in the problem itself will be given. The problem itself will be given as the power generation from first generating unit is 600 megawatt, second generating 400 megawatt, third generating 500. The problem itself will be given. Sometimes you need to take. Sometimes in the based on this, you need to frame, like the second example problem, like PG1 maximum values is not given. Okay, based on that, what how we have chosen is based on that minimum and maximum power generation. Power generation we have taken. Power generation we have taken as 600, 400, and 200. Like that we have taken. Okay, so here if it is not given, you need to consider. You need to consider in the some problems. If it is not given, you need to consider and you need to solve.